Okay, guys, so I'm going to try and record this in one piece. If it doesn't work, then I may just give up on this since the answer's already posted. And if you have any questions about it, then we can talk about it via WebEx or something like that. We're looking at Hess laws, practice problem answers. We want to determine delta H for each of the following problems. Use a separate piece of paper to show your work. You can always check your answer using molar enthalpies. So find the standard molar enthalpy for the reaction of carbon plus half of an oxygen to give CO. Given that C plus O2 goes to CO2 with a delta H of negative 394, and CO2 goes to CO plus half an O2, and that delta H is plus 283. Well, again, I always approach this from the sense of where do I want that carbon to be? So where do I want my in the final reaction that I want? Where are these things going to be? So C solid is going to be a reactant. So I'm going to use this one as is. For my other one, I'm going to look and I need to cancel that CO2. That'll get rid of the CO2 and I'll have an O2 here and half an O2 there. So I'm pretty sure I can just add these two together. Now, when I do that, the heck? Oh, that's why. Sorry. When I do that, what I end up with is C solid plus, and my CO2 cancels. It's CO2 over here. I have an O2, so I cancel half an O2 over here, and that leaves me with a half there. So C plus half of an O2 gas gives me CO gas. And to get that, I just need to add those two numbers. So negative 394 plus 283. And that gives me negative 111. Cool, that was awesome. Standard enthalpy changes for the formation of aluminum oxide and iron 3 oxide are 2Al solid plus 3 halves of an O2 goes to Al2O3. That has a delta H of negative 1676. And 2Fe solid plus 3 halves of an O2 goes to Fe2O3. We want to know what's the delta H for Fe2O3 plus 2Al goes to Al2O3 plus 2Fe. So my first reactant in this thing that I want is this Fe2O3. That's a product here. So I'm going to have to reverse this. And so when I do that, that's going to give me an Fe2O3 solid goes to 2Fe solid plus 3 halves of an O2. And of course, since I reversed that, that's going to be positive 824 kilojoules. My other one, I want to have Al2O3 as a product over here, and that's what I see there. So I'm just going to add these two together as they are right now. So add my 2, and of course I'm going to bring this to Al solid plus 3 halves of an O2 gives me Al2O3. And that is 1676, and that's negative kilojoules. So adding those two together, I end up with 2Al plus Fe2O3 solid. Cancel the 3 halves of 2's. That gives me 2Fe solid plus Al2O3 solid. And so if I add those two values together, I have 824 minus 1676, and it gives me negative 852 kilojoules. Okay, awesome. That's fun. Let's try another one. Coal gasification converts coal into a combustible mixture of carbon monoxide and hydrogen called coal gas in a gasifier. So H2O liquid plus C goes to CO gas plus H2. We want to know what the delta H for that is. We have the equations 2C plus O2 goes to 2CO. We have 2H plus O2 goes to 2H2O. And we have H2O liquid goes to H2O gas. So I want H2O liquid. And I only have H2O gas here. So what I see first is I need to take this 2H2 gas plus an O2 gas goes to 2H2O gas. And that is going to stay the way it is, negative 484. I'm going to take this H2O liquid. Nope, actually, that is not what I'm going to do. Sorry. I had another thought, and I didn't think this through the way I should have when I started this. So if I look at what I want H2O liquid as a reactant. I have H2O liquid right here. So I'm going to use this as is. I want to have C solid. So that's going to be this equation, but I need to divide it by 2. So that's going to give me C solid plus half of an O2 gas to give me CO gas. And of course, that's going to be negative 111 kilojoules because I have to divide that by 2. Okay, that's awesome. So that'll give me my C solid. And that takes me to CO gas, which I already have. And then I need an H2 gas. Well, the only place I have H2 gas is right here in the second equation. But I need to reverse that. And I need to divide it by 2. So 1/2 and reverse. So the first thing I'm going to do is I'm going to do both of them. I'm going to have an H2O gas going to an H2 gas plus half of an O2 gas. And of course, I've turned it around, so it's now positive 484. 484 divided by 2 is positive 242 kilojoules. And now I have what I need, I think. Yeah, H2O liquid. So H2O gas. And this again is positive 4. So if I add all this together, I should get exactly what I'm looking for. So C solid. The H2O gas cancels with the H2O gas plus H2O liquid. And then my half an O2 cancels with my half an O2. So that's what I wanted here. Those are my two reactants. And that leaves me with a CO gas plus H2 gas, which is what I was expecting. So the H2 is right there. So I need to add those values together. So the negative 111 plus 242 plus 44. And that gives me positive 175. Sweet. Couple more. Only a couple, I swear. This coal gas can be used as a fuel. So CO gas plus H2 gas plus O2 goes to CO2 plus H2O. Predict the change in enthalpy for this combustion reaction from the following equation. So we have that 2CS plus O2 goes to 2CO. We had that before. CS plus O2 goes to CO2. And 2H plus O2 goes to 2H2O gas. Okay, so I want CO gas as a reactant. So I'm looking at CO gas as a reactant here. I see CO gas as a product here. So I'm going to reverse that. And I need to reverse and divide by 2. So CO gas goes to C solid plus half an O2 gas. And of course, if I reverse it and divide it by 2, it gives me positive 111 kilojoules. I need to have an H2, and it's only one H2 that I'm looking for right there. Okay, so I have an H2 here, but there are 2 of them, so I'm going to take 1/2 of that. So if I do that, that's H2 plus half of an O2, and that gives me 2H2O gas. Oh wait, it's not 2 anymore, it's 1. And that was listed as negative 484 divided 2, which gives me negative 242. So that gives me my CO in the right place, the H2 in the right place. I don't have my CO2 in the right place. So I don't have a CO2 being represented here at all. This last equation will give me a CO2, and I want it as a product. So I'm going to leave it as it is. And I'm going to add all of this together. So when I do that, and of course it's this equation with those two. So when I do that, I have a C solid from here. That cancels with the C solid that's there. I have an O2 that's here. I have half an O2 that's a product. Now, I can get rid of the half of an O2 and a half of an O2 there. That leaves me with an O2 that I want, which is O2 gas. Plus CO gas plus H2 gas. So I've gotten rid of, so the C solid I got rid of. I could have sworn I lined through that. And that gives me the CO2 from that first equation. And then I have plus H2O gas, which shockingly is what I'm looking for. So that means that if I add those three values together, so the negative 394 from the equation that I didn't rewrite, that carbon plus and O2 goes to CO2, plus the 111 plus negative 242, and that gives me negative 525 kilojoules. Sweet. Awesome. Use the following calorimetrically determined enthalpy changes to predict the standard enthalpy change for the reaction of ethane with chlorine gas. C2H4 plus Cl2 gives me C2H3Cl plus HCl. Okay, fine. C2H4. I'm looking for C2H4. I see C2H4 right there. It is a reactant, so I'm going to work with that as is. I'm not going to rewrite it. So this I'm going to take down. Cl2 I want as a reactant, and I see that right here, so I'm going to pull that down. C2H3Cl should be a product, so I'm going to have to reverse that. So when I reverse that, that's going to give me C2H5Cl liquid goes to C2H3Cl gas plus an H2. And of course, when I reverse that, that's a positive 140 kilojoules. Okay. So then I can take, and I have an H2 here and an H2 there, so I can cancel those. I have the Cl2, which I actually want, because I have a Cl2 in there. I have my C2H4, which is still there. I'm actually going to pull this over here. C2H4 gas. I have that Cl2 gas left, plus Cl2 gas. That's going to give me C2H3Cl, but I have to get rid of this first. So look, I was I reversed this. So I have this one here, C2H5Cl, and I have a C2H5 Cl here. Is that what I want? Yes. So C2H5Cl there, C2H5Cl there. So that's then going to give me the C2H3Cl liquid plus the, and there's one HCl left. So there are two here. There's one here. So I can cancel that one. And that leaves me with one HCl there. HCl gas. And so I can take and do happy math. And that means that the negative 185 minus the 65 plus 140. And that gives me negative 110. Cool. These are cool. I can handle this. So two more. And I'm actually going to let you handle those two on your own because we've done enough of these so that I think you should be comfortable handling this. And if you have any questions about these, please let me know. All right. I think we are good here. I'm going to go ahead and stop. There are other questions for you to answer in the practice that is available to you. So I'm going to stop recording and I will see you guys later.